The state of the AI and robotics race between the United States and China as of April 2026 has transitioned from a theoretical competition of algorithm into a grueling, material-based contest of industrial diffusion and physical integration. While the United States maintains a significant lead in the intelligence edge, the foundational large language models, LLMs, and advanced logic-based reasoning systems, China has secured a dominant implementation edge by embedding artificial intelligence into the physical machinery of its economy. This divide is most visible in manufacturing and robotics, where the physical AI gap has widened significantly over the last 2 years. As of early 2026, China has effectively become the world's laboratory for industrial automation. In 2025 alone, China installed approximately 300,000 industrial robots, bringing its total operational stock to over 2 million units more than the rest of the world combined. This scale has allowed Chinese manufacturers to cross the cost parity threshold for humanoid robots. In late 2025, the Shanghai-based company Agibot emerged as the global leader in humanoid shipments, delivering over 5,100 units, followed closely by Unitree with 4,200. These robots are not mere prototypes. They are being deployed in dark factories across the Pearl River Delta to handle logistics, quality control, and hazardous material management. In contrast, the United States remains the leader in high-intelligence robotics software. While American companies like Tesla and Boston Dynamics have produced more sophisticated and agile prototypes like the Optimus and the all-electric Atlas, their shipment volumes remain in the low hundreds as they prioritize perfecting the software-hardware feedback loop over mass-market saturation. The foundation of this robotics race is the magnet war over rare earth minerals. Permanent magnets are the essential components for the high torque, precision motors required for both humanoid joints and electric vehicle powertrains. China currently maintains control over 80% of the global production of heavy rare earths, such as neodymium, dysprosium, and terbium. Throughout 2025, Beijing implemented increasingly granular export controls on these materials, framing them as strategic security resources. To counter this, the United States has accelerated its Mineral Independence Initiative, investing billions into domestic processing at sites like Mountain Pass and developing urban mining programs. These programs utilize AI-driven sorting systems to extract rare earth elements from the millions of tons of decommissioned GPUs and consumer electronics produced annually, essentially turning the e-waste stream into a strategic mineral reserve to bypass Chinese geological dominance. In the military sphere, the doctrine of intelligentization has replaced traditional modernization in both capitals. By the end of 2025, Chinese models and military AI systems accounted for roughly 30% of global AI workloads, a staggering jump from just 1% in early 2024. The People's Liberation Army, PLA, has focused heavily on AI-enabled maritime domain awareness, deploying thousands of autonomous underwater vehicles, AUVs, and surface vessels to create a sensor-fused net across the South China Sea. These systems use machine learning to detect U.S. naval assets by analyzing acoustic and satellite data in real time. The U.S. response, centered on the Maven Smart System and Project Replicator, focuses on diffusion acceleration, the ability to rapidly integrate AI into existing hardware. The Pentagon's current strategy is to maintain a human-in-the-loop advantage using AI for rapid targeting and logistics while ensuring ethical oversight, a contrast to the PLA's aggressive pursuit of command loop automation to outpace human decision-making in the Pacific Theater. The integration of AI into everyday life has revealed a profound trust gap between the two populations. As of 2026, consumer trust in AI-driven services in China stands at 72%, compared to roughly 32% in the United States. This social license has allowed China to deploy AI at a level of granularity unseen in the West, from AI-managed power grids that reduce energy consumption by 15% to smart judicial systems that assist in small claims litigation. In the US, AI integration is largely invisible, embedded in productivity tools, financial algorithms, and entertainment. However, the American public remains deeply skeptical of physical AI, such as autonomous delivery vehicles and facial recognition, leading to a fragmented regulatory landscape where some states ban technologies that are becoming standard infrastructure in Chinese cities. At the core of this entire ecosystem is the management of data. China has officially categorized data as a factor of production alongside land, labor, and capital. The National Data Administration, NDA, in Beijing has launched the Data Element X plan, which aims to unlock the economic value of public data by making it accessible to private AI firms for training specialized industrial models. By early 2026, the value added of these core digital economy industries exceeded 10.5% of China's GDP. The United States, meanwhile, relies on the dominance of its cloud providers, Amazon, Microsoft, and Google to store and process the world's data. This has created a new era of data sovereignty conflicts, where the US fights to maintain the free flow of information, while China builds a fortress data architecture designed to sequester its domestic insights while ingesting as much open-source global data as possible to train its military and commercial models. The race is no longer just about who has the best code, but who has the best materials, the most data, and the fastest factories to turn that intelligence into physical power.